Hello students, welcome to my channel. Today I am going to discuss about a very well-known geometrical figure, that is the circle. Now what is circle? Circle is a plane figure, a two-dimensional figure. It is a curve which is traced by a point in a plane so that its distance from a fixed point is always a constant. That particular fixed point is the center of the circle and that constant distance is the radius of it. And that curved line is the circumference of the circle. Also, there are other parts of a circle which are known to everyone, right? So, you all know about chords of a circle too. What are the chords of a circle? A chord of a circle is a line segment which joins any two points on the circumference of it. And make sure, students, there are so many properties of the chords of a circle. Basically, in today's class, I am going to discuss about those properties. So, let's see what are those properties of the chords of a circle. So, our today's topic is chord properties of circles. So, here, if we take this circle, of which the center is at O, then we will find that the line segment which is joining any two points on the circumference of the circle, suppose I am mentioning these points as A and B, then that line segment is the chord of the circle. And make sure, students, there are infinite number of chords in a circle. Now, if you choose any two such points on the circumference of a circle, so that when you join them by the segment, that is by the chord, you find that the chord is passing through the center of the circle, then this particular chord is mentioned by a special name, that is the diameter. So here we get that diameter is also a chord, and make sure, students, this is the greatest chord in a circle, and it is also a chord which is passing through the center of the circle. Now let's see the first property. This property says that the straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. So let's illustrate. This is a circle. The center is at O. Okay. Now, as per this property, we get the straight line drawn from the center of a circle to bisect a chord. So this is the chord. Let's name it as AB. And hence the straight line is drawn from the center to this chord AB, so that it bisects the chord AB. Suppose it is bisecting the chord AB at the point D. Then what will happen? It becomes perpendicular to the chord. That means in this case we will find that this OD will be perpendicular to AB. So what is the property? The property is, if from the center of a circle you draw a straight line which is bisecting a chord, then you will find that that particular straight line is perpendicular to that chord. It's a very important property. So now let's try to prove this property. So in order to prove this statement, we need some additional construction, because it is clear to all of you that using this particular feature we cannot reach to the conclusion. So we need some additional construction. So what that construction should be, let's see. Suppose I am joining this center O to A as well as to B. Why? Because look, students, this construction will help us to get two different triangles, and hence easily we can use the congruency properties of triangle in order to prove this statement, right? So what is the construction? Here the construction is center O is joined to A as well as to B. Now let's try to prove the statement. Here we have got two triangles. One is this one, another one is this one, right? So triangle OAD and triangle OBD give. Look students, first of all we get that OD is the common side, right, to both the triangles. OD is the common side. This side is shared by both the triangles, right? Secondly, we get that AD equals to DB. Why? Because according to the given statement, we get that this line segment or straight line which is drawn from the center O to the chord is bisecting. It is bisecting the chord. Okay. So here we get that AD equals to DB. AD equals to DB according to the given condition. Thirdly, we get that OA equals to OB. Why? Because O is the center and here OA and OB are the radii. Plural of radius is radii, you know, radii of the circle, right? So here obviously, as we know, all radii of a circle are equal in length. So OA is equals to OB. OA equals to OB of the same circle. Radii of the same circle. Okay. So as per these three conditions, we can conclude that triangle OAD is congruent to triangle OBD. By which rule? By SSS, because three corresponding sides are here used for proving this congruency. SSS rule of congruency. Okay. So here we have shown that these two triangles are congruent. That means all corresponding sides and angles of these two triangles are the same, are equal in measurement. Okay. So here we can conclude that triangle ODA, means this one, is equal to angle ODB. Right? As all the corresponding sides and angles are equal. So we get angle ODA is equal to angle ODB. CPCT means corresponding parts of congruent triangles, right? So these two angles are equal in measurements. Hope it's clear to all of you, right? Now just observe students, if you add these two angles, that is ODA plus ODB, then what will be the result? The result will be angle ADB. Okay. Now angle ADB is a straight angle because ADB is a straight line. Right. So as this is a straight angle, so obviously the result of this summation will be 180 degree. So here we get angle ODA plus angle ODB equals to 180 degree. As angle ADB is a straight angle. Right? So we get ODA plus ODB equals to 180 degree. Now look students, we have already got this relation that ODA equals to ODB. Let's make this relation as relation number 1. So in the place of ODB, we can write ODA, isn't it? So we get ODA plus ODA equals to 180 degree. That means ODA, 2 into ODA equals to 180 degree. That means ODA equals to 90 degree. And this is also the value of angle ODB. So here we find from this figure that angle ODA means this one and angle ODB means this one. Both are 90 degree in measurement, isn't it? So we have reached up to this. We have got ODA equals to ODB equals to 90 degree. So what is the final conclusion? Yes, OD is perpendicular to AB. So here we can write OD is perpendicular to A. And this was the statement that the line segment will be perpendicular to the chord. And hence the statement is proved. So here we have seen that if a straight line is drawn from the center to the chord of a circle which is not a diameter, and hence if it is found that the straight line is bisecting the chord, then it is obvious that the straight line will be perpendicular to the chord. Now here is the second property. The second property is the perpendicular to a chord from the center of the circle bisects the chord. So here if we draw the figure, this is a circle with center O and this is a chord. Let's name it as AB. Now as per this property we get the perpendicular to a chord from the center. This is the perpendicular. These two angles are right angle. Okay. From center to the circle bisects the chord. So here we get that if we draw a perpendicular from the center to a chord, then we will find that the chord will be bisected by that perpendicular. That means here if this happens, then the conclusion is AD is equals to DB. Isn't it the converse of the previous property? Yes, hope you all have got it. That in the previous property we had seen that if a straight line is drawn from the center to a chord which is not a diameter and hence it is found that it is bisecting the chord, then the straight line will be perpendicular to the chord. But here it is given that the straight line drawn from the center to the chord is perpendicular. Conclusion is then the chord will be bisected by the straight line. So let's try to prove this statement. So I hope it's clear to everyone that we need some construction, because just by using this feature we cannot reach to the conclusion, right? So what construction? The same one, hope you all have got it already, that we have to join the center to A as well as to B. Why? Because in that case we will get two triangles and we can apply the congruency properties of triangle over them. So here the construction is the center O is joined to A as well as to B. So let's mention construction. Center O is joined to A as well as to B. Let's try to prove. Now look students, here we have got two triangles, triangle ODA and triangle ODB. So from triangle ODA and triangle ODB we get, let's see what do we get. First of all, look, OD is common. This is shared by both the triangles. OD is common side. Secondly, OA equals to OB. Radii of the same circle. Okay. So OA equals to OB of the same circle. Now what is the third condition? Just pause the video and think over it. What is the third condition? Yes, hope you all have got it, because it is given in the question. I have already marked these two parts, that this segment OD is perpendicular to AB, right? It is perpendicular to the chord. Okay. So what will be the third condition? Angle ODA is equal to angle ODB, right? So angle ODA equals to angle ODB by given condition, both 90 degree. Right? So here we get that three corresponding sides and angles are equal. Obviously the triangles are congruent. Now by which condition? Here the condition is RHS. Why? We have taken the right angle. Let's take one of these two triangles to judge that by which condition the triangles are congruent. Here we have already used the right angle. We have already taken the right angle. If we consider this triangle, we have taken this side. We have taken this side of this triangle, which is the hypotenuse, right? So here the condition is RHS. So this is the easiest way of judging that by which condition your triangles are getting congruent. So triangle ODA is congruent to triangle ODB by RHS condition. Just take one of the two triangles and see that which sides and angles are used for proving congruency, and then easily you can conclude that by which condition the triangles are congruent. So we have already proved that the triangles are congruent. So what should be the conclusion from here? As they are congruent, so all corresponding sides and angles of them must be equal. So can't we say that AD equals to DB? AD is the side of triangle OAD and DB is the side of triangle OBD? Yes, we can say, right? So AD equals to DB, corresponding parts of congruent triangles. And hence we get that the statement is true. What was the statement? The perpendicular to a chord from the center of the circle bisects the chord. That is here, this OD, which is the perpendicular to the chord AB, is bisecting the chord AB, and that is why we have already proved that, logically we have stated that AD is equals to DB. Hence the second property is also proved. So here is the third property of the chords of a circle. It says that equal chords of a circle are equidistant from the center. You know, there are infinite number of chords in a circle. There are infinite number of equal chords also in a circle. And all these equal chords have a unique property. That is, they are at equal distance from the center of the circle. Let's illustrate. This is a circle having center at O. Suppose AB and CD are two equal chords. So according to this property, we will find that the distance of AB and CD from the center are also the same. And hence make sure, students, the distance means the perpendicular distance, right? So if we draw two perpendiculars, OX and OY, suppose, from the center O to the chords AB and CD respectively, then according to this property, the measurement of OX will be equal to the measurement of OY. That means OX will be equal to OY. Now let's try to prove this statement, this property, logically. Hope you all have understood that from this feature we cannot reach to the conclusion or we cannot prove the statement. So we need some additional construction here too. And hence the construction is, suppose OA and OC are getting joined. So here O, that is the center O, is joined to A as well as to C. Because of the same reason, because this construction will give us two triangles and hence we can apply the congruency properties of triangles to prove the statement. So let's mention the construction. Center O is joined to A as well as to B. Okay. So with this construction, let's try to prove the statement. So what are there in our hands, students? Let's recall. We have already got that the chords are equal. The chords are equal. That means here we have already got that AB is equal to CD, right? And hence they are equidistant from the center. Means if from the center two perpendiculars are drawn, because distance means perpendicular distance, make sure of it. So if from center two perpendiculars are drawn to this chords, then we have to prove with all these informations that these two perpendiculars are of the same distance. Okay, that is, are of the same length. So let's try to prove the statement now. For proving this statement, we have to first select these two triangles, as you all have got it. So from triangle OAX and triangle OCY, we get, look students, first of all, we can conclude that OA equals to OC because radii of the same circle, right? So OA equals to OC, radii of the same circle. Now let's go for the second condition. Look students, these perpendiculars are drawn from the center to the chord, right? These two X and OY are perpendiculars from the center to the chord, right? So obviously they will bisect the chord, what we have already proved in the first two theorems, first two properties. Okay, so here we can say that angle OXA is equal to angle OYC, both 90 degree, because they were perpendicular distance according to the assumption. And thirdly, we can conclude that as they are bisecting the chord, so AX equals to CY. Why? Because the chords were equal in length. AB equals to CD. So, and also we have known that we have from the previous properties that these perpendiculars will bisect the chords, that is OX will bisect AB as well as OY will bisect CD, right? So, as they are bisecting the chords, we can say half of AB, as AB equals to CD, so half of AB is equal to half of CD. Bisection means division into equal parts, two equal parts. Now, half of AB means what? AX. And hence it is CY. So, we have concluded that AX equals to CY. That is, in order to prove this statement, we have taken the help of the previous properties. Hope it's clear to everyone. So, here three conditions. OA equals to OC, OXA equals to OYC, and AX equals to CY will help us to conclude that triangle OAX is congruent to triangle OCY. Now, by which rule of congruency? Let's select one of these two triangles. If you see OAX, you will find we have taken this side, this angle which was right angle, and also have taken this side. So, RH, this is the hypotenuse, S. So, by RH's condition, of congruency, we can conclude that triangle OAX is congruent to triangle OCY, right? Now, as they are congruent, so obviously all the corresponding sides and angles of these triangles must be equal in measurement. So, from this we can conclude that measurement of OX, length of OX is equal to length of OY, as they are corresponding parts of the congruent triangles. So, we get OX equals to OY, corresponding parts of congruent triangles, CBCT. hence the statement is proved, and hence we found that equal chords of a circle are always equidistant from the center. Here I would like to mention one thing, that is, as we have already proved that equal chords of a circle are equidistant from the center, then make sure students the converse of this statement is also true. That is, if you find that any two chords are there which are equidistant from the center, that is, the perpendicular distance from the center of the circle to the chords are equal in measurements, then also you can conclude that the chords are of equal length. That is, the converse of this statement is also true. Now let's consider another property. It says that equal chords of a circle always subtend equal angles at the center of the circle. Okay? So let's illustrate. This is a circle having the center at O. These are two equal chords, AB and CD. Now, as per this statement or as per this property, here we will find that these chords will subtend equal angles at the center of the circle. That means these two angles will be equal, provided the chords are equal, right? So let's try to prove this property, prove this statement logically. So here we want to show, required to show that angle AOB is equal to angle COD, right? And what are the informations in our hand? That is, first of all, the chords are equal in measurement. Actually, this is the only information. And also another one is they are subtending angles at the center. We have to show that these angles are equal in measurement. So here, according to the statement, we have already got two triangles, right? One is triangle AOB, another one is triangle COD. So let's work with them. So we are first considering triangle AOB and triangle COD. We get the first thing what we can see here, that is AB equals to CD, because it was given that the chords are equal in measurement, right? So AB equals to CD. Okay, as according to the as per the given condition. Now what is the second one? What is the second condition? Look students, AO, OD, OC, OB, all these are the radii of the circle, of the same circle, right? So obviously their measurements are equal. So we can conclude that OA is equals to OD, radii of the same circle, and by similar logic we can say that OB equals to OC. Okay, so here three corresponding sides are equal between these two triangles. So obviously they are congruent to each other. By which rule? Think over it. Yes, I hope you all have got it. By SSS criteria of congruency. Okay, so triangle AOB is congruent to triangle COD by SSS criteria or condition of congruency. Okay, so these two triangles are congruent. So obviously all the corresponding parts, corresponding angles and sides of these two triangles must be equal. Okay, so here we can conclude that angle AOB is equal to angle COD. So angle AOB equals to angle COD, CPCD, corresponding parts of congruent triangle. and hence the statement is proved. So here we have seen that if two chords are equal in measurements, then they will subtend equal angles at the center of the circle. And make sure, student, the converse statement, the converse of this statement is also true. That is, if you find that two chords are there and they are subtending equal angles at the center then of the circle, obviously, then you will conclude that these chords are equal in measurement. So here in this video, we got all the properties of the chords of a circle. The first one was the straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. And also we have seen the converse statement, the converse of this statement is also true. That is, if we find that a straight line which is passing through the center of a circle is perpendicular to a chord of it, then it will obviously bisect the chord. Secondly, we have seen that equal chords of a circle are equidistant from the center, and hence also the converse of this statement is also true. That is, if we find that two chords are at equal distance from the center of the circle, then we may conclude that the chords are equal in measurements too. Thirdly, we have got that equal chords subtend equal angles at the center of the circle, and hence also the converse statement is true. That is, if we find that two chords are subtending equal angles at the center of the circle, then we may conclude that the chords are equal in measurement. So watch this video very carefully, prepare these theorems, these properties. In my next video, I'll show that how these properties can be applied for solving different problems. Till then, take care, stay safe. Thank you so much.